Welcome to my classroom. This is Justin. Today I am going to talk about kurtosis. When you look at a distribution, there are four moments of a distribution. That means four ways in which we describe or try to understand a distribution. The first moment is the mean, the center point, mean, and the second moment is the variance of the data, how much data is scattered, and the third moment is symmetry of the distribution, that means skewness, positive skewness or negative skewness, or is it zero skewed data, and the fourth moment is kurtosis. Kurtosis is one of the most misunderstood concept in statistics. The common way in which we explain kurtosis is in terms of its peakness, how tall the curve is. If the curve is very tall, we generally call it as Lepto Kurtic. If it is flat, we call it as Platy Kurtic. And if it's something like a normal curve, we call it as a Meso Kurtic. So what is a mistake in that? The primary mistake is, or the most important mistake is, the peakness has nothing to do with the kurtosis values or the concept of kurtosis. It is basically not the peakness, it is actually the tail part. A thick tail is the indicator of a leptokurtic, and no tail is an indicator of a platykurtic. So that is a major difference in this context. For example, if you have a curve like this, there's no tail in the both ends. Okay, now nothing is there. So this indicates that there is not much deviation from the center. If you look at this is the average point, the deviation from the center is almost nil. So this is a platykurtic curve. Or if you have a data, the data would look like a uniform distribution. You have the frequency histogram would look like this. It's a platykurtic curve. What if you have a data which is almost like a normal curve, where in general data may vary from 0 to minus 3 standard deviation, and generally we don't write more than minus 3 standard deviation. Obviously there will be some values beyond it, but generally we don't write minus 4 standard deviation. The reason is that's a very small percentage, 0.13% of the data. And this is a simple usual mesokurtic. So this will be platykurtic and this will be mesokurtic. And third one is you have a long tail and you have a lot of possibilities here. You may have 5 standard deviation like that. Generally we can write up to 4. Not up to, there can be a lot of standard deviations like that, but 0.5 standard deviation also found to be meaningful when you think about a leptokurtic curve. See that? So this has nothing to do with the peakness of the curve, but in general we misunderstood this concept because it looks like a peak curve. See that? It looks like a peak curve, but actually the point is here. Do we have a data here? One of the example of a leptokurtic curve is a T distribution. T distribution is mostly a leptokurtic. So when you draw a T distribution in the, maybe I'm trying to impose another distribution here, it may be like this. See that? Now, in the older fashion, when you look at the concept of the kurtosis, you may say that, oh, this is more taller. The curve 1, we say this 1 and this is 2. Curve 1 is more taller than curve 2. So this has to be lepto? No. Leptokurtic is this condition, second curve, because it has a very long tail. We have a thick kind of tail. You have a lot of information. That means there are so many outliers from the data. It's a kind of indicator of standard deviation also. When you have more outliers, standard deviation of the distribution also tend to be very high. See that? The differences. And generally another term that we generally use related to the kurtosis is basically excess kurtosis. Whether excess kurtosis is positive or excess kurtosis is negative. That's a very serious thing. When you write the usual equation of a kurtosis, it is basically like sum of x minus x bar 4 raised to 4 divided by n, and this all divided by the basically the standard deviation of and 4 times of it. This is how you generally write a kurtosis equation. Now this score tend to be 3 for a mesokurtic curve. Generally a mesokurtic curve, the kurtosis value tend to be 3. It is an indication of how much data in this side and this side, like that. Okay, so when you rework, some people reworked in this equation and the equation is changed, -3 part also included in that, so that for a mesokurtic curve the kurtosis value become 0. See, this is called as excess kurtosis. If excess kurtosis is positive, higher value, we generally say that it's a leptokurtic curve, positive curve. And if the excess kurtosis is negative, we generally called as a negative kurtosis, that is a Platy Kurtic curve. Okay, so this is the indication of the excess part of the curve. It's an indication of kurtosis. Okay, so one of the reason people say that, one of the reason for developing such a confusion among statisticians are, when this concept was discussed by Fisher and Pearson, they have written a mistake in some of the article or some of the document that peakedness of the curve is indicator of the kurtosis. It is said that this is the reason many of the authors made this mistake. If you read many textbooks, that will tell us that peakedness of the curve is the indicator of the kurtosis. So let us have a very clear-cut understanding about what is a concept of kurtosis now. That's it. Bye from my channel.